Thank you. It's great to be here. Over the years, I've had the opportunity to attend many of the MicroHAMS conferences, and they've always been informative and a lot of pleasure. And as many of you know, I've also been fortunate to be able to videotape and post many of the presentations on my YouTube channel. Today, I'd like to tell you a story about a group of radio amateurs who set out upon themselves to build their own digital radio controller. This is truly an ambitious project, one that turned out to be more successful and rewarding than we could have ever imagined. At MicroHAMS 2018, it was a treat to hear from Dr. Joe Taylor. Also on the presenters list that year was this guy, John Langner. John, WB2OSZ, is the creator of Direwolf. I edited the video of John's presentation as well. And you know, when you're editing a video, you see it over and over and over again, more times than I would want to count. But there was something really simple in his presentation that stuck with me. It came back and jogged my memory, something probably most people would not have noticed. I dug around on my hard drive and found this slide from his presentation. It's exactly what I thought I remembered seeing. He was talking about 4 different devices that we could use to take sound out of our radio and put it into our computers. In particular, though, look at this little one right here. This stuck in my mind, and I especially remember this little green wire attached to it. The device, of course, is a USB sound card. You can get them for about $5, and John Langner was using one of them to send packet radio with Direwolf. The challenge is that you have to key your radio. That's where that green wire comes in. John explained to us that the chip inside these sound cards, the codec, has extra pins on it that are not necessarily implemented in cheap devices like this. Pins that would normally turn on LEDs and provide other kinds of status. By tapping into it, you can connect it to a transistor and create a push-to-talk circuit. One of the other devices on John's slides, however, was this guy right here. This is the UDRC from Northwest Digital Radio. It plugs onto a Raspberry Pi, and I don't know if I've ever had more fun with amateur radio until this came on. Digital radio really came alive. So what could be more fun than doing digital radio with a UDRC? Well, the answer is doing digital radio with a homebrew device, something that I designed and built myself. So hey, if John Langner says we can do it with a little sound card like this, there probably are better options out there. So I went looking. The Mount Baker Amateur Radio Club meets on the second Tuesday of every month in Ferndale, Washington. That is, we meet every month when we're allowed to get out of the house and go places. We hope that will return soon. On the third Tuesday of the month, a subgroup of the members meet again, and we call ourselves the Digital Group. We generally don't have any sort of formal agenda or procedures for these digital group meetings. Instead, it's a round table where people come and bring their own projects in, show and tell. They come in with questions, usually about digital radio or other ham radio projects that they might be working on. So I brought up the idea that I might like to build my own digital radio, and some of the other members said, hey, they'd do that too. Let me show you some of my early attempts here at doing this project. One of the first ones that I did was this guy right here, this controller board. This, you see I have a little DC-DC buck converter on there. I've got some 6-pin mini DIN jacks, some LEDs, and I got these wires going off here. The problem is that this is going to plug onto a sound card, and one of the first sound cards I came up with was this guy. It's called the audio injector, and I'll show you a picture online of what it actually looks like, because I've kind of hacked it up here. Probably the biggest problem with this sound card are those red and white RCA connectors. They're too tall and they get in the way. When you put your own board on top of this one where our controller is supposed to go, all that plastic was in the way. So I experimented with trying to carve them off and get it shorter. It kind of made a mess of things. In the end, I went as far as to actually remove them from the board, and I was going to just solder my own wires on there and figure out some way or another to move the sound in and out of the sound card and up to the controller. There were 4 RCA jacks on the board for bringing the audio in and out, and it's got some pots on there that you could use to set the levels, and we experimented with it. It worked. This board would plug in there. I only have a single set of pins right there because that's all I needed to use, and that was the kind of header that I had for this. The board is one I do up using a program called Fritzing, and then I upload them to a company. Actually, it's this company right here, JLC PCB in China, and they make up the boards for me and send them back, and they're kind of inexpensive. It's very doable. So one of the things that I learned right away on this, here I got a Raspberry Pi I can show you, when you put your sound card on the Raspberry Pi, gosh, it's all tangled up. So when you put the sound card on the Raspberry Pi, it has to be this shorter size because you have all of these devices, the Ethernet jacks and the USB jacks over here on this side. So that sort of dictates the size of this board. And one of the first mistakes I made was that I thought my board would have to be the same size and that they would go together and have the same footprint. As soon as I put all this together, I realized that once you've added the sound card to the Raspberry Pi, you're up above all of these guys. So I learned right away that I could go to a larger footprint because I'm up higher, I'm above the connectors on the Pi. I'm up here like this, and the sound card is in between. So the sound card has to be smaller, but the controller card doesn't. Well, that was all fine and dandy, but I want to show you in particular a picture that showed up a month later. We're working on this project that KF7 VOP put together. KF7 VOP brought this into a digital club meeting about a month later after we started this project. And you'll see on top that there's the audio injector sound card, the same one that I was using. And notice here, this device right here is actually a 6-pin mini DIN connector, which is going to go over to the radio. Let me zoom in here. Can you see what's going on down here? This is something, it's a technique that we used to call dead bug style. Dead bug style is when you take your electrical components and you simply bend the leads around and solder things together. So VOP's got transistor in here and some resistors hooked up, and they're all just soldered dead bug style, and they run over to the 6-pin mini DIN, and that's how we key the transmitter, and it worked. Well, let's see if we can make some sense out of this mess. Here we've got this board right here. This was my first board. We call this the Rev A board. Here's another version of it right here. And the point here was we got these wires because somehow got to move the audio back and forth between these boards, and we're experimenting with these sound cards. Like here's another one of the audio injector boards, and I haven't hacked this one up. That was cool. And then this board right here, I experimented with this. This is an earlier version of the FeePi, which you're going to hear more about. And it uses these RCA connectors, and we've got little 3.5 millimeter ends on the other. And this is sort of like I'm slowly figuring out what's going on. And then at one point in time, we're having a digital club meeting, and my friend Steve, you're going to see him later in this video, Steve, AG7GN, has been working on this project as well. And he comes up with the idea of using another version of this board. It's called a FiPi, but it's a smaller footprint. Here it is on their website over here. It's like 16 bucks. It's not expensive and it works really well. I've got one over here. In fact, this one with the arrows on it actually came from Steve. I've removed a connector here, not intentionally. It was accidental. These are little speakers that go in cell phones. And I was able to use these to get the audio. There's magnets on there, so that's why they jump to each other. I was able to take the input and output audio and run them to these speakers. The FiPi is designed to go on a Pi 0, but it'll go on a Raspberry Pi 3 or even a Raspberry Pi 4. As soon as I saw these connectors right here, though, the light came on, because I use these connectors all the time in my CW decoder and my CW keyer kits, and I have hundreds of them. So I went, oh, now I know how we can move the audio in and out, or back and forth, I should say, between the boards. And I'll show you what we have is these little jumper cables. It's a 6-inch cable, and we use these to move the audio between the two boards. I don't know why it took me as long as it did to figure that out. I mean, I was getting close here, and this probably was close to that. We've got the A boards right here. This is Rev A, and as I said before, they're shorter, and I realized I didn't have to restrict myself to that limit. This board was our Rev B board, and I was doing something interesting here because I added the Rj45 connector here, and doing something like SignalLink does. SignalLink is set up so you can put jumpers across here, because not all radios are the same. So if you bring in a connection, Rj45 connection in from your radio, it comes in here, it goes to these pads, and then we have to put appropriate jumpers in to get it to come out right at the on the other side to go to the rest of our circuit. And I put these larger pads in here thinking that, you know, we would solder jumper wires in there and there'd be a nice way for people to solder wires on there. And I've got some more of those boards right here. When I order a set of boards, typically I would get 10 boards. You know, it says $2. We used to be able to get 10 boards for $2 from this company, and they have switched now to only 5 boards for $2. But for most projects, you're prototyping, you know, do you really need 10 boards? Except because we had a group going and we're working on this project, I would order 10 boards, and then we'd pass them out around the table, and 6 or 8 of my friends would take them, and they'd all be building them up as well. So that's the Rev B boards. The next one that we did, this guy, and this is a Rev C, and the difference is that we went to these sockets here, sockets that we could put jumpers on. And if you see those, we're basically imitating the SignalLink. These jumpers right here on this board here are identical to what you would put on if you had a SignalLink. If you have a cable for a SignalLink, it's already good to go. You could plug it into our board, put the jumpers in the same way you would for the SignalLink. So this is our Rev C version, and I think I have some more of those boards also. I think I may have ordered as many as 20 of the Rev C boards. Have a few of those left over. Notice in here, you know, you see this power deck that we put on. that goes over this space right here, and down here, well, this is where we're putting all of the resistors for the circuits, because every LED needs a current limiting resistor, and then all of our switches and everything else that goes on will require a either a pull-up or a pull-down resistor. So the project has progressed. Now, looking at these boards and seeing all this stuff attached to them, I should point out that we're able to create things like this because some of the boards that we need are already created for us. They're called breakout boards. And about a week or so ago, I did a short video about the breakout boards, the breakout boards that we use for the Nexus project. Let me pause here for a minute and switch over, and I'll run that video for you right now that talks about all the various breakout boards that you don't have to build because they're already built, that you can use in your project. So take a look at this. Today, amateur radio do-it-yourselfers have a great advantage over those from past times. Not only do we have integrated circuits that make building circuits and projects easy, we also have available numerous breakout boards. Breakout boards are small printed circuit boards that are already populated with the parts to perform a particular function that we may want to use in our project. They're usually built with surface mount parts, things that maybe we would rather not have to do ourselves. Let's take a look at some of the boards that we use in the Nexus DR-X. Of course, we have the Raspberry Pi. It's all built up and ready to go. It's got all the connectors on it that we will need to run the computer end of our project. Next, we're going to add to it a sound card. This is a sound card that we prefer to use. This one is called the Pi, and it's available online for about $16. It has both capture and playback jacks on here to handle the audio going in and out of our radio. To make the whole project work, we'll need a power supply. This is a DC to DC buck converter. It's an efficient way to create the voltage that we need to run everything: the Raspberry Pi, the Pi sound card, and our Nexus board itself. You just have to be sure that you set this voltage with this control right here before you hook these your board up to either the Pi or the Raspberry Pi, because it's set at a fairly high voltage to begin with, and we need to dial it down to about 5 volts. In addition to that, we're going to add this little tiny breakout board here. It's inexpensive and it's very, very handy. You see, the Raspberry Pi does not include a clock. Every time we boot up a Raspberry Pi, it comes up back in January 1970, and you need either the internet or some means to set the clock on your Raspberry Pi. By using this little breakout board here, it's called a real-time clock, or we say RTC. This board will maintain the time for us even when the project is not powered up. It comes with its own battery attached. These are not expensive, easy to include in your project, and they work great. Finally, I've got an interesting little breakout board here. This is a jack. It's called a TRS Jack. That stands for tip ring sleeve. It's a surface mount part that's already attached to a board. We attach it to our board with some headers. Now, it's interesting that I am able to get this board here soldered up and ready to go cheaper than if I bought the parts separate. So that's kind of why we go this route. It also means that our builders don't have to do any surface mount soldering. So those are the key breakout boards that we're going to use on our Nexus DR-X. Now let's take a look at the Nexus board itself. We'll take my whole unit apart. Now, if you look down here, this one is actually on the air right now. In fact, I can key my transmitter, right over here, and you'll see this blue LED comes on while I'm transmitting a simple identifier on FSQ. So we want to shut this down, and to do this I'm going to use this little button that you see right here. Okay, I'll hold this button down, the green light will come on, and then when it goes off I'll let go, and that'll do a proper shutdown of the Raspberry Pi. So here we go, I'll hold it down. 2 seconds later the green light comes on. After 5 seconds the green light goes off. And now if you watch the blinking LED, if you're familiar with a Raspberry Pi, you'll see down here when this blinks solid and then goes out, the Raspberry Pi has shut itself down completely and safely. I can pull the plug and don't have to worry about any files that may have been being written while we did that. So I've got these two cables right here marked K and Y. This goes to my Kenwood radio, and this one goes to my Yaesu radio. I'm running both of them at the same time. The Kenwood is running FL-Digi and running FSQ. The Yaesu is running Direwolf and is working as a digipeater, and they both run at the same time on this setup. Okay, so let's see, we'll unplug one of the patch cables here, or both of the patch cables here. This is why we call it a cross patch. These little 6-inch cables link the audio from the VPi, which is hiding underneath down here, up to the Nexus DR-X itself. Now, there's a trick to removing a 40-pin connector. You don't pull and bend and yank on it. All you have to do is rock this board back and forth, just gently. You don't have to do it very hard. Let me show you at this angle. All I'm doing is rocking it like that, and as I do that, this connector is walking off of those 40 pins. So I just go back and forth and it comes apart. It's that simple. We have, of course, an HDMI connector down here that's running my monitor, and that is part of the Raspberry Pi. In fact, it's that connector and maybe some USB stuff. This is a little dongle for my keyboard and mouse. I'll remove these plugs, get them out of the way. I don't think I need to take this apart. You can see the VPi is there. Notice it is half the size of the Raspberry Pi. That's because this is set up and configured for the same size as the Pi Zero, but they use the same connector, so it works just fine on the Nexus boards. Now that we've got this apart, let's take a look at what's on this board and find out what all these little components are doing. Well, probably you'll notice right away that we have here two of these 6-pin mini DIN connectors right here. One is for the left radio and one is for the right radio. Next to them we have a piano switch, and we'll talk more about the piano switch a little bit later, but it's fully programmable. Each one of these switches goes to a GPIO pin on the Raspberry Pi, and you can decide exactly what it is you want those pins to do. For example, the way I have it configured right now, this pin 1 is down. That will launch FL-Digi on my left radio, and pin 4 is down. It will launch Direwolf on my right radio. Here are the audio connectors right here. This is the receive audio here, and this is the transmit audio there. So this is stereo, so they're going in and out of these connectors as left and right channels. Then the circuit inside the board will split those up and cross them over to these two separate connectors. So the left RX rod audio goes to here, and the left TX audio goes to the same connector, and the right RX audio and right TX audio cross over to the right connector. Of course, you can see there's our power deck right there. Our buck converter is in position. Here we have two jumpers, and these jumpers allow us to switch between 1200 baud and 9600 baud coming in from the radios. On this side of the board, we have a power jack. This is a DC barrel jack that you can put in anywhere from, say, 9 to probably 28, 32 volts of DC will come in here. Our buck converter is adjusted and it will put out exactly 5.2 volts to run everything that's in the stack. On this side, you'll see an Rj45 connector. This Rj45 connector right here simply goes to these 8 pins right here on this IC socket. We use this socket as a jumper header, and on the other side of this socket we have connections that go to the left RX audio, to the left TX audio, the handle push to talk for the left hand side, and there's ground. So this connector right here is a substitute for this one over there. You can use either of these two, but not both at the same time. This connector, if you might recognize it, is identical to the connector that's inside of Tigertronics SignalLink. If you have a SignalLink cable on one of these jumpers, you can plug it right in here, or you can go to their website and look at the pattern for jumpering wires right on there as well. Here's our real-time clock, as we talked about earlier. I'll just go ahead and unplug it, and you see it just plugs in on the board right there and maintains time for us. The underneath the board, this is our TRS connector. This was set up originally so that you could hook a TRS cable that goes to some of the radios, such as Baofangs and BTEC radios. They take a connection like this. And just like we did with the Rj45, this connector right here goes to these 4 sockets right here, and they're labeled tip, ring 2, ring 1, ring 2, and sleeve. And the other side of them take care of the RX audio and the TX audio and the push to talk for the right radio. So this connector right here can be a substitute for that one there. Also on the board we have some LEDs. The red LED comes on when you're keying your right transmitter. The blue LED comes on when you're keying the left transmitter. There is a green LED that comes on when we use the switch, as you saw me do just a few minutes ago. There's a couple transistors in here. The transistors are that handle the push-to-talk circuit that keys our radio. I like to add connections for other projects. So I have pins here for 5 volts and ground, and over here I have pins for 3.3 volts and ground. So if you have a project that uses those voltages, you can pull power, like I do, off of these pins and run another board doing something else that you might want to do. Finally, we have these pins right here, which are a standard UART connector. So we have TXD and RXD here in the center with a ground, and the 4th pin has no connections, which is a standard plug that you can put on there and get into your Raspberry Pi from a PC or a laptop. So that pretty much covers everything that's on the board, and we'll put it back together and talk about how we use it. When we first started making these boards, I really wanted to call it a DigiLink. Maybe you can see it here on the printed circuit board. We thought DigiLink had a great sound to it. It would be a perfect name for this board, but unfortunately this name DigiLink is already taken. So we had to come up with something else, something that would be ours. And searching Google for all the various combinations, pretty much everything's already taken. But I'm reminded of my past. When I was a young child, probably before I was a teenager, my father, who was a ham radio operator, ran a phone patch every week for a serviceman in Korea. My dad would contact the base where he was stationed, and a radio operator there would put this guy on the radio. And then in Tacoma, where we lived, my father would phone this guy's wife, and they would talk. And he did this every week for months and months and months. And that's called a phone patch. And I'm looking at our Nexus board here with these patch cables in it and realizing that, this is basically the same thing. We're patching, obviously patching, audio from something that was never intended to be on the radio through a board and using a push-to-talk circuit so that we could switch a transmitter on and off onto our radios. And so that's where I came up with the idea of calling it a Nexus, which is linking, the Nexus DR-X, which stands for Digital Radio Cross Patch. It seems to fit well. Many of our Mount Baker Amateur Radio Club members are also members of the Bellingham Makerspace, and that makes sense. We're do-it-yourselfers. So on several occasions now, we've grouped up at the Makerspace in Bellingham and had build parties. Here are a few photos from some of those sessions. They're a lot of fun. We build up the boards, we test them, and we actually get them on the air before people go out the door. Well, those build parties are a lot of fun, and we've had several of them. We look forward to a time when the COVID thing gets over and we can get together. There's a list of people already waiting to go to the next build party, and we'll look forward to having that happen. So just so you know, you don't have to get everything off the shelf at HRO. There's a lot of ham radio equipment that we can build ourselves, and these build parties are fun. In fact, I'll never forget the look on Anne Marie's face. Here she is at a build party. She had put her Nexus board together, took it over to the bench where we hooked up the power, and she set her voltage at 5.2 volts. If you could have seen the look on her face, the satisfaction and the delight that she saw it working, that she had built it, she did it, that was just precious to be able to see that. Well, here's our board back on the air again and running. And with all of the stuff attached to it and all of the options that you see here, this is what I would often call or refer to as the Swiss Army knife of digital radio, with all the choices you have and things you can do. If you're interested in building one of these things, go to my website at wb7fhc.com. Take a look at the info that's there about the Nexus project, and there is a form that you can put your name on a waiting list, and we'll get back to you and let you know when there's an opportunity again for you to build one of these. One of the things that we like to do at those build parties is load up your SD card and make sure that all the software you need to enjoy and use your Nexus DR-X is ready to go and working. And Steve Magnuson, who has done most of the work on writing that software, usually comes along and oversees that process for you. I had an opportunity to talk with Steve in a Zoom meeting, which I recorded so that I could share it with you. Steve will tell you all about the software and the image. Take a look. Hey, Steve. Thanks for joining me on this little project, and we certainly appreciate all the work that you've done. Steve and I have worked together on our Nexus project for some time now. He gives me hardware requests and I give him software requests. But this certainly would not be the project it is if it wasn't for his efforts and his contributions. So Steve, introduce yourself and tell us what you've been up to.
Well, thanks, Bud. My name is Steve Magnuson, AG7GN. And I've been working with Bud for probably a year now, maybe even more than that, on the image that we use on the Nexus DR-X board. Now, prior to that, I worked for Boeing as a network engineer, and did a lot of work with Linux. So the transition to the Raspberry Pi and Linux in general in the ham radio world was sort of natural to me. And one thing I noticed with that, even though the Raspberry Pi had some pretty significant adoption in the ham radio community, there was still a bit of a learning curve for those, especially for those hams who really aren't interested in understanding operating systems. They just want to operate the Raspberry Pi ham application in order to operate their radios. So I saw a need there and developed an image based on the standard Raspbian image in which I overlaid a set of scripts that allow you to run a graphical user interface or a GUI, and you can configure various ham applications that way. You can operate them. You can update the ham applications or install them if they're not already installed in a way that's more familiar to those hams who are used to using, say, Windows or a Mac, rather than on the command line that you often find with Linux. So that was the genesis of my project. And I started this independent of the Nexus DR-X board project that Bud was working on. And we worked in parallel without really knowing what the other was doing for quite some time. And eventually we crossed paths and discovered, well, there's a certain, quite a few synergies here, and decided to team up and make this project work in a variety of different applications for a lot of different hams.
Well, that's great. So you want to show us what you've got?
Sure. Let me share my screen here. Okay, so this is a Raspberry Pi that I'm operating here at home. This particular Nexus board is mounted on a Pi 4, although the board, of course, will work on a Pi 3 or a Pi 3B. The first thing you see is the background image, and this is the standard background image, although it doesn't come equipped with a call sign. So one of the simple scripts I added was the ability to change the name of your background image, to put your call sign or whatever you want in there. And that's under the Preferences menu under Edit Background Text. So you can put your call sign in there and then toggle this checkbox if you want to include the host name of your Pi or not on there. So that's how that works. The other thing I added was the ability to turn on auto hotspot. A lot of hams are using these Raspberry Pis in applications for MCOM use in Go kits, and they're often away from the internet and no other network connection. So in order to VNC into them, like I'm doing here, where I'm remotely controlling the Raspberry Pi with VNC Viewer, they would like to turn the Raspberry Pi into a Wi-Fi hotspot and connect to it that way. So I wrote a GUI around a script that is popular on the internet for the Raspberry Pi for this purpose. You can go in and set your SSID and the hotspot password, select what channel you want to operate, and it can automatically detect whether you're running a Pi 3, which only has a 2.4 gigahertz Wi-Fi, or the later models, the 3B or the 4, which has both a 2.4 and a 5 gigahertz password. But most of the scripting that I've done is found in the ham radio menu. And if you click on the Raspberry Pi in this ham Pi image, you can see several items in here. These are organized by left and right radios. As Bud has explained, you can see the Nexus DR-X board supports 2 radios at the same time. And there's a left radio and a right radio. So I set up FL Digi, FL Message, FL Amp, and FL ARQ already configured to use the left radio or the right radio. Now in this case, I have the names of my radio programmed in here. Normally the left would appear up here and the right would appear down here. But there's another script I wrote called Name Your Radios, in which you can name the left radio and name the right radio. By default, they just say left radio and right radio. So that's kind of a convenience for those hams who want to know which radio is which. I also have some scripts that can control Direwolf. This first one is a one where you can configure the Direwolf TNC and monitor the output from Direwolf in a window here. So these tabs, this is the monitor window shown. There's a configure TNC window here where you can select which audio interface you want to use. And up here is some guidance on which one you should use for the left radio and right radio, push to talk, the AGW port, KISS port, and the rate of the sound card and which Direwolf modem to use. And then there's another tab for configuring PAT. For those of you who don't know, PAT is a Winlink client, and it is works pretty well. It provides a web interface as well as a command line interface, and it's designed to work with a TNC like Direwolf. So you can go in here and configure PAT to your liking and set up which ports it wants to listen to, and certain AX25 parameters are listed here as well that you can program. And then the output, when you click restart Direwolf and PAT, it restarts Direwolf and PAT, and you can see the output here. And either connect to this with a Windows machine over the same network via Winlink to the Direwolf application, or you can open a web browser to your Pi and go to this URL and see the PAT web interface that provides a Winlink client. I also have a radio monitor here. This is an application that shows when the push to talk is activated on either the left or the right radio. So if you're running FL-Digi or Direwolf or any other ham application that triggers to push to talk via the GPIO, these indicators turn red to show when you're transmitting or receiving. And there are also some controls here to start a radio receive audio monitor or the transmit audio monitor. You can send the audio output from the receive side or the transmit side to a set of speakers that are connected to your Raspberry Pi. The way that FL-Digi and the other ham applications are set up in here, it's designed to use the Pulse Audio application. And Pulse Audio is an audio server that allows you to share the audio devices in a way that doesn't cause a conflict between the software packages. This application here is the first one I wrote. I think it is the first one I wrote. And this is to manage the installation and the updating of various Pi and the Raspberry Pi operating system and associated applications, as well as ham software. And if you run this application, it brings up a graphical user interface that lists all of the possible programs that I have enabled in a script that you can upgrade. So this is the first script, for example, is a script I wrote for rig control for the Kenwood 710 or the 71A. ARM is in there, auto hotspot I showed earlier, chirp for programming your radio, Direwolf, etc. And there's some other applications down here, some of which I manage also. The IP tables rules, RMS gateway software, some utilities, JS8 call, etc. So if they're already installed, it will show that here. You just check the box and you click OK, and it'll go out and see if there's any updates, and then you can, it will automatically install those updates for you if you want. If it's a new installation, it'll show up here as not installed yet. You check the box and it'll install that program. Some of these applications, it will also configure them at least minimally for you. Other applications, you'll have to configure them yourself. There's so much variety in these applications as far as how they're configured that it's difficult to script that part of it. All of the ham applications that are controlled via this Update Pi and ham software menu item will appear in this menu here. So you can select any of these from the menu. You can also rearrange the items on this menu if you want to. The reason you see FL-Digi and FL-Message appear here by themselves instead of up here is that I've installed an alpha version of them down here that I'm experimenting with right now. Normally, a regular user typically wouldn't see this information down here. Okay, just to give you a demonstration of this updater application or this script that I wrote, the one thing I should mention too is that this updater application automatically updates itself whenever it's run. So it goes to my GitHub site and downloads the latest version. And it will prompt you if there's a new version to ask you to rerun the script again. So for example, if we look for, let's pick one of these that's already installed, HAMPI utilities, for example, and we click OK, you get some feedback in this screen as to what it's doing. What it does is it does a Pi update, but not an upgrade. And it will go out and look for that particular application, check the version number. So in this case, the installed version is the same as the latest version. So both the HAMPI utilities package is up to date and there's no need to update.
So Steve, this means I don't have to do this apt-get stuff every time I want to update something. I don't have to Google it because I can never remember what it is I'm supposed to do, and it is kind of frustrating. I can just go in here and check a box and click a button.
That's exactly right. You can check all installed by clicking this button here, and all of the installed packages will come back checked, and then you can click OK, and it will go out and see if there's any updates for those. Now, one thing I should mention, you will notice that this top line here has a strike through in it, Raspbian OS and apps. Normally that works. You can go out and grab the latest Raspbian and all of the other Raspberry Pi apps via this checkbox here. But I have this grayed out currently because back in January, the stable kernel that was released by the Raspbian organization contained a bug in it that broke the FeePi software that ran the FeePi card. In other words, it disabled audio on the FeePi card. So I discovered it, fortunately, before any of the other users of HAMPI did. And so I sent out a note and updated my HAMPI updater, and I disabled this temporarily until a new stable version can be released. And they have not released a new stable version with the fix in it yet. The FeePi folks were notified of the problem, and they contacted the kernel maintainers for Raspbian, and they came out with a fix, but they have not released the stable version with that fix yet. So for the time being, you cannot update the Raspbian operating system using my updater because I intentionally disabled it so it wouldn't break people's Nexus DR-X boards when they're using the FeePi card.
But Steve, we know there is a fix. I mean, they figured out what was wrong and figured out how to fix it, but it's not in a release that we can grab and use. Us garden variety hams and Linux users can't get at it yet.
That's correct. They have, it is available in kernels that you can download. I'll call them test kernels or bleeding edge kernels, if you will, that have all the new updates. Those are often released every few days. However, the stable kernel, which is what most users want to be on, does not have this fix in it yet. The fix was actually incorporated about 90 days or so ago. And I have tested it in those bleeding edge kernels on another Raspberry Pi, and I know the fix is in there. They just haven't been rolled into the stable kernel yet. And as soon as they have, then I'll issue a new version of my updater, and this strike through will disappear, and you'll be able to once again update the Raspbian OS.
Hey, that's great, Steve. So if somebody wants to put this on their board, if they want to put it on their computer, two questions. One is, where will they go to find it? And the other one is, will this work with boards other than our Nexus DR-X?
Yeah, those are great questions. You can, the best place to download the image is to go to Bud's website on the web page where he has the Nexus DR-X information. And there's a link on that page to my GitHub site. And that'll take you to a README document which has all the instructions on how to download the image, how to install it on an SD card, how to burn it to an SD card rather, and then put it in your Pi and boot it up.
And what about someone that's using a different sound card or a different way? Will your menus work on any other Linux implementations?
In most cases, no. And the reason for that is a lot of these graphical user interfaces that I've written specifically are looking for the FEPI audio card. And they are specifically expecting that the GPIO is going to be on pins 12 and 23 for the left and right radios respectively. So this very much is a Raspberry Pi image, although it's based on Raspbian and you can get all the standard Raspbian updates for it, is very much customized for the FEPI card and the Nexus DR-X board.
Well, that's great to know, and I could certainly say that I have gone to your GitHub site and I have followed your directions and successfully installed this. Your directions are really clear, really easy to follow. There's not a lot of assumptions. If a person is following Steve's instructions, just go step by step. Follow them through there. If you already know a lot about Linux, you can skip over and breeze over some of the details that he provides. But if you're new to this, like so many of us are, Steve, you've just done a great job of making them clear for all of us.
Well, thanks very much, Bud. When I was first starting out on Linux, that was a very big frustration for me as well. And the documentation is very hit or miss. Some folks up there who write Linux applications write fantastic documentation, and other writers, other programmers, their documentation assumes a lot. They assume you know a lot about Linux, and they can skip over a lot of steps. So I've spent a lot of time making sure my documentation is as complete as possible for those hams who aren't interested in Linux. They just want to make it work.
Okay, Steve. Well, thank you very, very much for joining me here and giving us this arm-waving tour of the work that you've done. I'll make sure that everybody has a URL on the screen. It's wb7fhc.com. And if you go there, there's a whole column about the Nexus board, and you'll be able to find the instructions that Steve is talking about. Hey, 73 Steve, thank you so much.
Thanks much, Bud. 73's to you as well.
Well, that winds up my role in this MicroHAMS 2020 video conference. Please stick around and watch my friend Andy, KF7VOL. He's going to do a presentation on digital radio in Whatcom County, and I'm pleased to say that our Nexus DR-X boards play a significant role in many of those installations. So, back to mission control. 73, everyone.